Hi, it's Mrs. Moret with help on today's assignment, page 209, numbers 1, 2, 4, and 7. In problem number 1, it says the cost for an upcoming field trip is $30 per student. The cost of the field trip C in dollars is a function of the number of students X. So the cost is a function of the number of students. Okay, that means that the cost is the output and the number of students, X, is the input. And so it says to select all the possible outputs for the function defined by C of X equals 30X. So the cost is going to be equal to 30 times each student. So the question is, are these possible costs of the field trip? So if the cost were equal to 20, then and every student costs $30, 20 divided by 30 is not a whole number. It's actually not even equal to 1. So there's no way this could be the total cost if each student costs $30. Could the cost be 30? Sure. If just one student went, the cost could be 30. So we'll circle that one. Could the cost be 50? Well, could you spend $50 when each student costs $30? Well, that's not a whole number. So we would expect to have a whole number if we're talking about the number of students. So I'm going to cross that one off. And then the next one, how about 90? Well, since 90 divided by 30 is equal to 3, then this could totally happen as long as only 3 students were on the field trip. And then finally, could the cost be 100? Well, 100 divided by 30 is also not a whole number. So again, because the function represents, the cost for so many students, then we would have to get a whole number because it represents the number of students. So we're going to cross that one off. So just B and D. Okay, the next question, number 2. A rectangle has an area of 24 centimeters. Function f gives the length of the rectangle in centimeters when the width is W centimeters. Okay, since the function gives the length, that means that the length is the output and it's dependent on the width. So the width is the input. So here we're asked to determine if each value in centimeters is a possible input of the function. It's asking us if these are possible values in centimeters of the width of a rectangle. Okay, so I know that in a rectangle has length and width, and they have to be positive numbers because if it was 0 or if it was a negative number, we wouldn't have a rectangle. It's not possible. So this is not possible. This is not possible. And because these are all positive numbers, if we have a width of 3 and the area is 24, the length would just be 8, so that works. And then 0.5 or 1/2, sure, it would just be really long and skinny, but it's possible. And then kind of the other way around with the 48. All right, so just those 3 values. On number 4, remember you skipped 3, so go to 4. A small bus charges $3.50 per person for a ride from the train station to a concert. The bus will run if at least 3 people take it, and it cannot fit more than 10 people. Function B gives the amount of money that the bus operator earns when n people ride the bus. Okay, so it sounds to me like it's $3.50 per person. That's important. There's a minimum number of at least 3 people have to be on the bus, and it can't hold any more than 10. So between 3 and 10 people on the bus. So where it says to identify all numbers that make sense as inputs for the function. Okay, sure. So the input is going to be the number of people riding the bus. So we could have, so we'll just say inputs. You could have 3 people on the bus. These are riders. 4, 5, 6, and I just drew some dots up to 10. Okay, so whole numbers between 3 and 10 because it has to have at least 3 and no more than 10. So then for the outputs, the output is going to be the cost. So, sorry, I should have highlighted. The inputs are the number of people, and the outputs are the money that the bus operator is going to earn. Okay, so inputs are the number of riders on the bus, and the outputs is what the bus driver earns. I'll say earnings. Okay, so for the outputs, well, if 3 people are riding the bus, then the bus driver earns $3.50 per person, which ends up being $10.50. If 4 people are on the bus, then the bus driver makes $14. If 5 people are on the bus, then the bus driver makes 5 times $3.50. So that is going to be $17.50. And so on. Up to 10 people on the bus, 10 times $3.50 is $35. So that's why the answer for the output is multiples of $3.50 between $10.50 and $35. So every time a new rider is on the bus driver is making $3.50 more. So to graph that, well, there's not going to be an input value until we get to 3, okay? And 3 riders is $10.50. I'm going to actually use a highlighter to shows that better. Okay, that's for 3 riders. And then for 4 riders, it goes up to 14, about there. And then $17.50 for the next one. And then 21. These should line up perfectly. I'm not doing the best job ever, but really close. 6 riders or 7 riders is $24.50. Really close to 25. And then 8 riders is $28, about there. 9 riders is $31.50, and 10 riders is $35 even. I'm not going to connect the points on this one because connecting the points would mean that there's a possibility of values in between these points. And because the riders on the bus are going to be in whole numbers, there aren't any possible values between them. All right, we're almost done here. We're ready for number 7. Get my camera to catch up. There we go. Okay, so this is a review of what we did on, well, you took this assessment actually before spring break. So I'm going to start by, we're matching features with the coordinates on the graph. So I'm going to just start by highlighting 0, 7. 0, 7 is where x is 0 and y is 7. It's that point right there. And because it's touching the y-axis, it's called the vertical intercept. Okay, at the vertical intercept, the x value in the coordinate is always 0. The next point is 1.52. It's this point right here in pink on the graph. And it looks to be the very lowest value the graph ever reaches. So we're going to go ahead and match that with the word minimum. Next is the point 416. 416 is right here. And it looks like that's the very highest point on the graph. So I'm going to match that with the maximum. And so the one that's left, the horizontal intercept, well, that's going to match with the term none because this is the horizontal axis and there isn't any point of that graph that's touching it. So for horizontal intercept, none is the correct choice for that. All right, that is the end of your assignment. I hope the help was helpful.